Welcome curious minds and sleepy thinkers. You found a soft place to land, a quiet corner of the night where the questions are big and the pace is slow enough not to jolt you out of your pillow cocoon. Let the gentle hum of the world outside fade away and allow your thoughts to become as soft and vast as the darkness that fills the spaces between the stars. Tonight, we're going to tiptoe into one of the most mysterious questions ever asked by the human heart, one that takes us to the very edge of what we know. We are going to gently explore the idea of a cosmic leviathan, a being of impossible gravity and mind-bending age, a creature of starlight and shadow that should not exist yet, undeniably does. But don't worry, we'll take it slow. This isn't a race through a textbook or a lecture on physics. It's more like floating through a galaxy of ideas with a cup of warm chamomile tea, letting the gentle current of a story carry us along. We will use metaphors as our guide ropes, simple words as our stepping stones, because the most profound truths are often best found in the soft glow of a candle, not the harsh glare of a spotlight. Tonight's journey is not about finding answers, but about finding wonder in the questions themselves. And perhaps a little peace in the knowing that there are still so many beautiful things left to discover. Our journey begins with a name that sounds more like a gentle whisper in a library than the roar of a cosmic giant, TON-618. This name belongs to an extraordinary object, a kind of lighthouse in the cosmic ocean, a beacon so bright it defies all reason. It is what we call a hyperluminous quasar, a term that sounds complicated, but really just means a powerhouse of impossible light. Imagine a single candle in your hand, and now imagine it shining so brightly that it outshines every city on Earth, all the streetlights and stadium lights and windows all at once. That's a small-scale thought experiment to help us begin to grasp the idea of TON-618. It shines with the light of over 140 trillion suns, a number that our minds can't hold. So let's simply imagine a furnace, so hot, so immense, that it burns with a furious, joyous brilliance, a testament to the raw energy of the universe. This brilliant lighthouse is not in our neighborhood. It's located in a peaceful little constellation known as Cons Venatici, which translates to the hunting dogs. It is a lovely, quiet name for a place that holds such a noisy, energetic secret. But the real story is not in its location in the sky, but in its distance from us. TON-618 lies more than 10 billion light-years away. To truly feel that, let's not think of it as a number. Instead, imagine a single lonely photon of light, a tiny messenger of hope that began its journey toward us 10 billion years ago. That light started its travels when our own solar system was not yet a glimmer in the cosmic dust. It was a time when the universe itself was still a newborn less than half its current age. Our Earth, our Sun, our Moon, all of the things we hold dear, simply did not exist. The light we see from TON-618 tonight is not a snapshot of its present self. It is a message in a bottle, a postcard from the distant past, telling us a story of a time that feels almost like a dream. And in that story lies a great and beautiful paradox. The light from TON-618 is from a time when the universe was young. Yet the object itself is a cosmic leviathan, a creature of such staggering size and maturity that it feels older than time itself, or so it seems. We would expect a young universe to be filled with young, small things, with stars just beginning to ignite and galaxies just starting to coalesce. But out there at the edge of our vision and the beginning of our story, we see a giant. This giant already had a mass of 66 billion suns, an impossible number that we can try to hold in our minds for a moment, a number that feels like a whisper of a myth. This is the heart of the puzzle, the question that floats in the quiet between our thoughts. How could a newborn universe give birth to a fully formed titan? This is not a tale of a single simple object, but a story of a window. TON-618 is our cosmic time machine, a portal that allows us to look back not at our own history, but at the grand epic and mostly unknown history of the cosmos itself. When we turn our telescopes towards that brilliant beacon, we aren't just observing a quasar. We are peering into the cosmic nursery, trying to understand how the first great structures of the universe came to be. We are looking for the fingerprints of the forces that shaped the galaxies, the subtle whispers of gravity and light that set the stage for all that followed. And in this act of looking, we are reminded of the immense scale of the cosmos and the beautiful fragility of our own place within it. So let us rest our minds on this thought for a while. A light that is 10 billion years old. A black hole that is a behemoth. A gravitational monster yet so far away that its brilliance feels like a gentle hypnotic pulse in the night sky. We will not rush to an answer about how it came to be. We will not force the pieces of the puzzle together. Instead, we will simply allow ourselves to be filled with quiet awe, embracing the mystery of this thing that defies our models and our expectations. It is a reminder that the universe holds secrets far more magnificent than anything we could have ever imagined, and that sometimes the greatest comfort is found not in knowing, but in the peaceful, gentle act of wondering. To continue our journey, let's unpack the very idea of a quasar. The name itself is a curious one, a shortened version of quasi-stellar radio source. In the early days of radio astronomy, these objects were little more than points of light, too faint and distant to be resolved, yet they screamed with powerful radio waves. They looked like stars or quasi-stellar, but they were emitting an energy no star could ever produce. They were cosmic pretenders dressed up in starlight, but powered by a secret engine far grander than any sun. This mystery was like finding a tiny firefly that cast the shadow of a dragon. The quasar we now understand is not the object itself, but the incredible light show produced by its engine, a supermassive black hole. The quasar is the music. The black hole is the composer. The quasar is the brilliant, chaotic storm. The black hole is the quiet, perfect eye at its center. And what a storm it is. The quasar's intense luminosity is not the gentle glow of a campfire, but the raw, uninhibited energy released as matter falls into the black hole. Imagine a vast, swirling maelstrom of gas and dust, a cosmic whirlpool drawn into the inescapable gravity well of the black hole. This material doesn't just fall straight in. It spirals, it compresses, it collides with itself at speeds we can barely comprehend. The friction is so intense, the pressure so immense, that this matter heats up to temperatures of millions, even billions of degrees. At these temperatures, it no longer exists as gas or dust, but as a brilliant, superheated plasma, a soup of subatomic particles radiating energy across the entire electromagnetic spectrum. This is the accretion disk, the fiery ring that gives a quasar its legendary brilliance. It is a cosmic forge where gravity is the hammer and matter is the steel-shaping light and energy in a display that is both terrifying and sublime. The light from this process is what we are seeing, a light that has journeyed across 10 billion years of cosmic history. But what does a 10 billion year journey mean for that light? It means that as it traveled, the universe was not standing still. The cosmos itself was expanding, stretching out like an impossibly large rubber sheet. This expansion has a profound effect on the light from TON-618. As the universe stretches, so too do the wavelengths of light traveling through it. This phenomenon is called cosmic redshift. It's like a gentle tug of war on the light itself. By the time that light reaches our telescopes, it has been stretched so far that what began as brilliant ultraviolet and X-ray emissions, the high-energy screams of the quasar, have been shifted down the spectrum. We now see it in the far red and infrared part of the spectrum. TON-618 appears to us not as a blinding white light, but as a reddish ghostly whisper, a testament to the vast epic stretching of space-time itself. This gentle shift in color is the universe's own fingerprint, a mark of its age and its unending journey of expansion. This brings us back to the central paradox, the impossible question that hangs in the quiet air of our thoughts. How could such a gargantuan object, a fully formed black hole of 66 billion solar masses, have come into being so early in the universe's history? Our current models of black hole growth are like a set of slow, methodical instructions. They suggest that black holes start small, perhaps from the collapse of a massive star, and then grow over billions of years, slowly accumulating matter and occasionally merging with other black holes in chaotic galactic collisions. This process is a marathon, a slow and steady climb over eons. But TON-618 is like a runner who has finished the marathon in the first 10 seconds of the race. Its existence defies the timeline we have so carefully drawn. This contradiction is not a failure of science. It is a beautiful invitation to wonder. It means there is a gap in our knowledge, a blank page in our cosmic history book that we have yet to write. Did the early universe have conditions so different from today that black holes could form in entirely new ways? Could vast primordial gas clouds have collapsed directly into massive black holes, bypassing the stellar phase entirely? Or perhaps was the very fabric of the early universe so dense, so rich with matter, that black holes could simply gorge themselves at a furious, unprecedented rate? We do not have the answer. And in this moment of not knowing, there is a certain kind of peace. It's the peace of standing at the edge of a great ocean, knowing there are still vast, uncharted depths to explore. The mystery is not a void, it is a promise. And what a beautiful promise it is. TON-618 stands not just as a single isolated object, but as a profound clue. It is a fossil from a time before time, a whisper from the cosmic dawn. By studying its light, by trying to understand its impossible existence, we are essentially acting as cosmic archaeologists, sifting through the ancient ruins of the universe. Every observation, every calculation, every quiet thought about this cosmic leviathan helps us to piece together the grand story of our universe. A story that began long before we existed, a story that we are just beginning to learn how to read. The existence of TON-618 reminds us that the universe is not just a stage for our drama. It is a living, breathing entity with a deep and mysterious past. So let's close our eyes for a moment and allow this thought to settle. A light 10 billion years old. A black hole 66 billion times the mass of our sun. A paradox that challenges everything we thought we knew. But instead of feeling overwhelmed, let's feel the wonder. Let's feel the quiet curiosity of a child looking at the stars for the first time. The universe is a place of beautiful secrets, and TON-618 is one of its most magnificent. The journey to understand it is a journey into the heart of our own wonder, a journey that has just begun. Let's drift a little deeper now, beyond the shimmering beacon of light and into the very heart of the mystery. The brilliant light of TON-618 is like a gorgeous song, but what is the voice that sings it? The answer, as is so often the case in the universe, is a quiet, powerful darkness. At the core of that breathtaking quasar is a central black hole, a thing of such immense gravity and scale that it is almost more a concept than a physical object. We can imagine it as the engine of the entire phenomenon, the quiet, insatiable heart that powers the impossible brilliance we see from billions of years away. Now let's try to hold a number in our minds that our minds simply were not built to hold. The black hole at the center of TON-618 is estimated to have a mass equivalent to 66 billion suns. Think about that for a moment. Our sun is a colossal furnace, a star so powerful that it dictates the lives of all the planets in our solar system. Now imagine stacking 66 billion of them, one on top of the other, compressing them into a space smaller than the distance between us and the nearest star, and then watching them disappear into a single, lightless point. That's the kind of scale we are talking about. It's the difference between a single drop of water and an entire ocean. It is the difference between a pebble and a mountain range, It is a mass so vast that it creates a kind of cosmic well, a deep depression in the very fabric of space and time from which nothing can ever return. To give ourselves a little more perspective, let's bring it closer to home. We know that our own galaxy, the beautiful Milky Way, has a supermassive black hole at its center, a gentle giant we call Sagittarius A/E. It is a respectable cosmic citizen, weighing in at about 4 million solar masses. TON-618 is about 10,000 times more massive than our own galactic heart. It's like comparing a house cat to a blue whale or a firefly to a forest fire. And even when we compare it to other more famous black holes, like the one at the center of the galaxy Messier 87, which was the subject of the first ever direct image of a black hole, the comparison is humbling. The M87 black hole, a true heavyweight in its own right, has a mass of about 6.5 billion suns. TON-618 is still roughly 10 times more massive. It is not just big. It is in a league all its own, a class of objects we now call ultramassive black holes. This comparison isn't just for fun. It is a profound lesson in the scale of the universe. Our own black hole, Sagittarius A, is a quiet sleeping giant. M87's black hole is a more active, energetic beast, but TON-618 is a roaring furnace, a cosmic maelstrom that defies all our easy metaphors. Its immense scale forces us to rethink what is possible. We must abandon our terrestrial ideas of size and weight and instead gently open our minds to a kind of vastness that is both terrifying and beautiful. And so we arrive at the central mind-bending paradox of this cosmic giant, its age. The light we see from TON-618 tells us a story that is 10 billion years old. This means that the black hole itself, when it was producing that light, was in a universe that was only a fraction of its current age. We are seeing a black hole that was already a behemoth, a fully formed titan at a time when the universe was still in its cosmic infancy, a time of first stars and nascent galaxies. This is like finding a 100-year-old oak tree in a garden planted yesterday. It simply should not be. Our current models for black hole growth suggest a slow, deliberate process. A black hole begins as a small seed, perhaps from the death of a single massive star. Over millions and then billions of years, it slowly, patiently consumes the gas, dust, and stars around it, like a creature grazing in a cosmic field. It is a process of accretion, of gradual accumulation. And if a black hole gets particularly lucky, it might find itself in the center of a galactic collision where it can merge with another black hole, gaining a huge chunk of mass in one chaotic event. But even with these processes, a black hole should not, by our current calculations, be able to grow to 66 billion solar masses in such a short cosmic time. The math just doesn't seem to add up. This is not a flaw in the universe. It is a flaw in our understanding. It means there is a missing piece to the puzzle, a secret to the universe's great story that we have not yet uncovered. The existence of TON-618 is a beautiful challenge, a gentle nudge from the cosmos, to remind us that we don't have all the answers. It suggests that there must be other ways for black holes to form and grow, ways that are faster, more efficient, and perhaps more violent than we ever imagined. Perhaps in that incredibly dense and chaotic early universe, there were other paths to greatness. One theory suggests that black holes like TON-618 didn't start as small seeds from stars at all. Instead, they might have been born from the direct collapse of massive primordial gas clouds. Imagine a cloud of gas so vast, so heavy, that instead of collapsing into a star and then a small black hole, it simply collapsed in on itself, forming a giant black hole from the very beginning. It's like a different kind of cosmic birth, a shortcut to being a titan. This would explain how a giant could exist in a newborn universe, bypassing the slow methodical process of stellar evolution. Or perhaps the early universe itself was a more fertile, more frantic place than we imagine. Maybe TON-618 was simply a hungry giant in a cosmic smorgasbord. feasting on a much more abundant supply of gas and dust than is available in the more sedate, spread-out universe we inhabit today. Its growth could have been fueled by a constant torrent of matter, an endless feast that allowed it to grow at a ferocious, unprecedented rate, a rate that would be impossible today. It's a compelling thought, a universe full of frantic energy and cosmic chaos, a beautiful, turbulent place where the rules of today simply didn't apply. The very shape of space and time around this cosmic behemoth is a lesson in the power of gravity. Its immense mass creates a deep gravity, well, a kind of depression in the very fabric of space-time. Imagine a heavy bowling ball placed on a stretched trampoline. The ball makes a deep dent, and any small marbles that roll nearby will be drawn into that dent. TON-618 is not a bowling ball, but a cannonball creating a dent so deep, a curvature so extreme, that it dictates the movement of light and matter for vast distances. This deep well is the silent, invisible architect of the quasar, shaping the swirling accretion disk and guiding the powerful jets of energy that scream from its poles. It is a powerful, elegant example of Einstein's theory of general relativity at its most extreme, a place where gravity is not just a force, but a sculptor of reality itself. In the end, what we are left with is not an answer, but a profound sense of awe. TON-618 is more than a black hole. It is a question mark, a puzzle, a beautiful cosmic mystery that reminds us of the limits of our knowledge. It tells us that the universe is not a simple, predictable machine, but a dynamic, creative entity full of surprises. Its existence pushes us to dream bigger, to ask better questions, to look not just for what we expect, but for the impossible things that defy our imagination. We can find a certain comfort in this. The universe is not a finished book. It is a story still being written, and we are lucky enough to be here, listening to the gentle whispers of its most ancient and mysterious tales. Now let us turn the pages of our cosmic storybook back to a more recent chapter, not of cosmic infancy, but of human discovery. The magnificent light of TON-618, a journey of 10 billion years, finally reached our home, but it was not immediately seen for the titan it was. Its story on Earth began not with a grand pronouncement or a flash of genius, but with a simple, methodical catalog entry. In the year 1970, a survey of celestial objects emitting strong radio waves was underway. It was a patient, humble task, like a librarian meticulously sorting through ancient scrolls one by one. This survey, conducted by the Ohio State University, was looking for peculiar radio sources that also appeared bluish in color. And in that vast, quiet search, they found it a curious flicker of radio noise and a subtle spot of blue light. It was given a name that sounded like a whisper, an unassuming code in a long list of cosmic addresses, TON-618. At that moment, no one fully understood what they had found. The object was classified as a quasar, but the true nature of quasars was still shrouded in mystery. They were simply bright, distant enigmas that defied explanation. The prevailing theories of the time were still grappling with the idea that such immense power could come from a point-like source. The idea of a supermassive black hole at the center of a galaxy was a concept still taking shape in the minds of theorists. It was a bit like discovering a beautiful humming seashell on a beach and not yet realizing that its sound was the echo of an entire ocean. The discovery of TON-618 was a quiet note in the symphony of science, a seed planted in the fertile ground of curiosity, waiting for the decades to pass and for the knowledge to grow. The slow unfolding of the truth about TON-618 is a beautiful testament to the nature of science itself. It is not a sudden epiphany, but a patient, collaborative journey. For decades after its initial discovery, TON-618 remained a peculiar bright spot in the sky. As astronomical instruments and techniques improved, our eyes on the cosmos became sharper, more sensitive. We developed new ways to see not just invisible light, but across the entire electromagnetic spectrum. This multi-wavelength astronomy is like being given a series of new senses. It's not enough to just look at a painting with your eyes. You are now able to feel its texture with your fingertips, hear the sound it would make if it were music, and even sense the heat radiating from its surface. With these new senses, we began to see the true nature of TON-618. Our radio telescopes could hear its deep, powerful hum, a cosmic bass note that revealed the presence of energetic jets screaming from its poles. Our optical telescopes, with their increasingly powerful mirrors, could capture the full dazzling brilliance of the quasar, allowing us to measure its immense luminosity and its distance with greater precision. And then, the true scale of the central black hole began to reveal itself. By studying the movement of gas and dust swirling around its heart, astronomers were able to measure the powerful gravitational influence of the unseen object at its core. They were able to weigh the invisible, a feat of both mathematical genius and profound patience. The results of these measurements were, to put it simply, breathtaking. The small, unassuming catalog entry, TON-618, was now revealed to be a colossus, a black hole of 66 billion solar masses. It was a discovery that didn't happen in a single day, but unfolded slowly, piece by piece, over decades. It is a story of human perseverance, of generations of scientists building upon the work of those who came before them, each adding a new brick to the magnificent cathedral of cosmic knowledge. This long, quiet process of discovery is exemplified by the different tools we have used to observe this ancient light. Think of the Sloan Digital Sky Survey, which first began to map the universe on an unprecedented scale. It was like a census of the cosmos, meticulously cataloging millions of galaxies and quasars, including TON-618. This was our first attempt to truly understand the sheer scale of the cosmic population. Then came the Hubble Space Telescope, our all-seeing eye in the sky positioned above the blurring veil of our atmosphere. Hubble's crisp, high-resolution images allowed us to see TON-618 with a clarity that was once unimaginable. It was as if we had squinted for years, and now, for the first time, we were putting on a perfect pair of glasses, finally seeing the details of the cosmic tapestry. But our journey of observation is far from over. The future promises even more profound insights. The James Webb Space Telescope, with its ability to see in the infrared, a wavelength perfect for observing the most distant, red-shifted light, is now our new great hope. James Webb is not just an eye, but a warmth-sensing finger, a hand feeling the faint, gentle heat of the early universe. Its observations will allow us to peer through the cosmic dust and gas that might obscure our view, giving us an even clearer picture of the quasar's inner workings and its host galaxy, which has until now been almost entirely obscured by the quasar's brilliant light. This is our next step, our next great leap into the past. And let us not forget the role of ground-based observatories. The Very Large Telescope in Chile and the Very Large Array in New Mexico have been instrumental in our understanding. The Very Large Telescope, a collection of 4 massive mirrors working in concert, is like a symphony orchestra, with each instrument playing a different note to create a more complete picture. The Very Large Array, with its vast network of radio dishes spread across a desert plain, is like a massive ear listening to the deep resonant echoes of the universe. These terrestrial giants remind us that even from our small home on a planet in a quiet corner of a vast galaxy, we are still able to reach out and touch the very edges of existence. This journey of discovery from a faint flicker in 1970 to a well-studied cosmic giant today is a humbling one. It reminds us that our understanding of the universe is not a finished book, but an ever-evolving story. The cosmos is full of beautiful surprises, and often the most profound truths are those that take the longest to reveal themselves. We began our story with a simple, quiet name, TON-618, and through the slow, patient work of generations, we have begun to uncover a legend of a cosmic titan that defies all our expectations, a ghost from the distant past, whose story we are only just beginning to learn how to tell. Having journeyed through the cosmic library of TON-618's discovery, let us now step directly into the roaring furnace at its heart. We have spoken of the quasar's light and the black hole's gravity, but let's now feel the heat, hear the roar, and see the terrifying beauty of the environment where these two forces collide. We are now in the accretion disk, a place of cosmic extremes where matter and energy perform a ballet of sublime violence. Imagine a whirlpool but not of water. This is a whirlpool of gas dust and countless stars all being drawn inexorably toward the deep silent well of the central black hole. This cosmic maelstrom is not gentle. As the material spirals inward, it accelerates to unimaginable speeds, its particles rubbing against each other with such friction and force that the temperatures soar. Think of the heat of the sun and then multiply it by 1,000,000. The innermost regions of this disk can reach temperatures of millions of degrees, transforming matter from a familiar state into a superheated soup of plasma. It is a state of matter so energetic, so chaotic, that it can no longer be contained within the familiar boundaries of atoms. It is in essence a cosmic forge where the very building blocks of the universe are being hammered into pure energy. This incredible heat is the source of the quasar's impossible brilliance. The plasma in the accretion disk radiates enormous amounts of energy across the entire electromagnetic spectrum. We're not just talking about visible light, but a full symphony of cosmic emissions from deep resonating radio waves to searing high-energy X-rays and gamma rays. This radiation is so intense that it creates an immense outward pressure, a light so powerful it actually pushes against the very matter that is trying to fall into the black hole. This is a delicate and dynamic balance, a cosmic tug-of-war between the inward pull of gravity and the outward push of light. This struggle, this glorious incandescent conflict, is what makes TON-618 shine with the brightness of over 140 trillion suns. It is the engine's exhaust, the composer's final resounding chord. But the dance of destruction does not end there. From the poles of this cosmic maelstrom, two powerful focused beams of particles scream out into the cosmos. These are the relativistic jets, and they are one of the most stunning features of this ultra-energetic environment. Imagine a spinning figure skater drawing their arms in to spin faster. The black hole's rotation, along with its powerful magnetic fields, acts on the superheated plasma in the accretion disk, channeling a small fraction of it and flinging it outward at speeds approaching that of light. These jets are not just faint beams of light. They are powerful streams of high-energy particles and radiation capable of influencing the evolution of galaxies for thousands, even millions of light years in every direction. They are like cosmic flamethrowers, cutting a path through the intergalactic medium and leaving a profound, indelible mark on the universe around them. The mere existence of these jets tells us a great deal about the environment of TON-618. They suggest that the black hole is not just a passive consumer of matter, but an active dynamic force, a cosmic engine that is converting the raw material of the universe into light energy and motion. The power of these jets hints at the immense gravitational forces at play, forces that we can only begin to understand through the lens of Einstein's theory of general relativity. In this environment, space and time are not just a static backdrop. They are a malleable dynamic fabric being twisted and warped by the immense presence of the black hole. The very laws of physics as we know them are pushed to their absolute breaking point, and in that breaking we find new and deeper truths. And so we must linger for a moment on the idea of this environment as a cosmic laboratory. We cannot, and likely never will, recreate the conditions around TON-618 in a laboratory on Earth. The temperatures, the pressures, the gravitational forces, the sheer scale of the energy involved, these are all beyond our current technological reach, but by simply observing this distant maelstrom, we are given a unique opportunity to study the behavior of matter and energy under the most extreme conditions imaginable. We can watch as gravity and light perform their delicate dance. We can measure the energy of the screaming jets, and we can test our theories of general relativity and quantum mechanics in a place where they are forced to confront each other. TON-618 is a natural experiment, a gift from the universe that allows us to peek behind the curtain and see the fundamental forces of reality at play. The swirling maelstrom of the accretion disk also tells us a story about the black hole's past. The light we see is a record of its consumption, a luminous memory of all the gas dust and stars it has devoured over the eons. The sheer brightness of the quasar suggests a prodigious feeding rate, a hunger that is almost beyond our comprehension. To shine with the light of 140 trillion suns, TON-618 must be consuming matter at a furious pace, likely hundreds if not thousands of times the mass of our sun every single year. It is a feast of galactic proportions, a cosmic banquet that has been going on for billions of years, a testament to the insatiable appetite of this cosmic giant. This constant furious consumption is also a clue to the black hole's impossible size. The universe of today is a much more sedate, spread-out place. Galaxies are drifting apart, the supply of gas and dust is more limited, and black holes are, for the most part, much quieter. But TON-618's existence in the young universe suggests a different reality, a time when the cosmos was denser, more chaotic, and full of an abundance of cosmic food. It was a time of cosmic gluttony, a feeding frenzy that allowed this black hole to grow to an unimaginable size in a relatively short period of cosmic time. So let us rest our minds on this image for a moment. A vast, swirling disk of superheated plasma, a brilliant maelstrom of light and energy. At its heart, a silent, invisible point of infinite density. And from its poles, two screaming jets of pure power cutting a path through the empty darkness of intergalactic space. This is the environment of TON-618, a place of profound beauty and immense violence, a testament to the raw, uninhibited power of gravity and light. It is a place that challenges our imagination and pushes the boundaries of our understanding. And in its breathtaking power, we find a new kind of peace, the peace of knowing that there are still wonders in the universe that are far grander and more magnificent than we could ever have dreamed. Having plunged into the fiery heart of TON-618, let us now ascend from the maelstrom and contemplate its profound meaning. The sheer existence of this cosmic leviathan isn't just an isolated curiosity. It is a profound lesson, a silent challenge, and a magnificent gift to the scientific mind. The quasar's distant light is more than just a beautiful spectacle. It is a cosmic anomaly that forces us to re-examine the very rulebook of the universe we thought we knew. For decades, scientists have built intricate and elegant models to describe the formation and evolution of galaxies and their central black holes. These models, like a set of meticulous blueprints, suggest a steady, predictable pace of growth. A black hole, we assumed, starts small and grows gradually, a slow, patient accumulation of mass over billions of years. This process is governed by a cosmic speed limit known as the Eddington limit, which describes the maximum rate at which a black hole can feed. Beyond this limit, the sheer outward pressure of the radiation from the accretion disk would be so immense that it would blast away any incoming matter effectively, putting a cap on the black hole's appetite. Our models are built on this principle, and they work beautifully for the vast majority of black holes we observe today. But TON-618 is the exception that breaks the rule. Its staggering mass of 66 billion suns, achieved in a universe that was only a billion years old, simply should not be possible according to these models. It's a paradox that stands as a towering testament to the gaps in our knowledge. Its existence forces us to confront the possibility that the cosmic speed limit might be a little more flexible than we thought, or that there were alternative, more ferocious pathways to greatness in the universe's chaotic youth. Perhaps the Eddington limit was a gentler suggestion, not a hard and fast rule in a universe teeming with a much richer supply of cosmic fuel. The light from TON-618 is not just a light from the past. It is a message from the edge of our understanding, telling us that our theories are incomplete, This is the great and beautiful power of a scientific anomaly. It isn't a failure, it's an invitation. TON-618 beckons us to look closer, to question our assumptions, and to dream up new possibilities. It pushes us to consider whether there were superseeds, exceptionally massive primordial black holes that were formed through some as yet unknown process, bypassing the slow, gradual growth of a stellar remnant. Or perhaps the early universe was a cosmic mosh pit of galactic mergers with black holes colliding and combining at an unprecedented rate, a furious dance of destruction and creation that allowed them to grow to an impossible size in a cosmic blink of an eye. The questions that TON-618 raises are not just about one object. They are about the very nature of cosmic beginnings, the first few chaotic and mysterious chapters of our universe's story. Furthermore, TON-618's existence has profound implications for our understanding of the relationship between black holes and their host galaxies. We have discovered a fascinating correlation called the M-sigma relation, which suggests a tight link between the mass of a supermassive black hole and the velocity of the stars in its host galaxy's central bulge. It's like a cosmic dance where the two partners grow in tandem, their steps perfectly synchronized. This relation implies a profound co-evolution, a beautiful story of a galaxy and its black hole growing together, each influencing the other in a delicate, millennia-long ballet. But TON-618, with its incomprehensible mass, seems to utterly dwarf its host galaxy. It's as if one of the dancers in the ballet suddenly became a towering giant, while the other remained a small, delicate figure. The M-sigma relation, so elegant and reliable for most galaxies, seems to break down in the presence of this cosmic behemoth. This breakdown is not a mistake. It is a clue. It suggests that perhaps in the most extreme cases, the relationship between a black hole and its galaxy is not one of equal partnership, but one of absolute dominance. Did TON-618 grow so large so fast that it began to dictate the terms of its galaxy's evolution, rather than the other way around? Did its immense gravity and powerful radiation outbursts shape the very structure of the galaxy, a silent, powerful architect of cosmic fate? Or could it be that this black hole is an ancient relic of a time before the M-sigma relation truly took hold, a vestige of a chaotic, unstructured universe that followed its own unique, forgotten rules? The questions are vast and beautiful, and they force us to consider new possibilities for how the intricate cosmic web of galaxies and black holes first began to form. So where does that leave us? We are left standing at the edge of a great mystery. The equations give up, and the simple, elegant models we have crafted no longer hold true. But perhaps this isn't a flaw in our journey, but a beautiful and peaceful invitation to simply wonder. TON-618 is a testament to the idea that the universe is not a finished book, but an unending story, a grand narrative with new and surprising twists on every page. It tells us that our understanding of reality is not a destination, but a journey, a continuous process of discovery and revision. And in this uncertainty, there is a profound sense of humility. The universe is not obligated to conform to our expectations or our tidy little equations. It is a wild, creative, and magnificent place, and we are but humble observers, standing in the quiet of the night, listening to the whispers of a cosmic giant from a time long ago. The scientific importance of TON-618 lies not in the answers it gives us, but in the questions it inspires. It is a reminder that the great unknown is not something to be feared, but a beautiful space for us to explore, to dream, and to find a certain kind of peace in the knowledge that the universe is always, always full of beautiful surprises. We have explored the magnificent paradox of TON-618's existence, the impossibility of a cosmic titan in a newborn universe. Now let us turn our minds to the quiet work of imagination, the beautiful human process of building theories to explain the unexplained. In the face of a mystery as profound as this, science does not simply surrender. Instead, it offers a series of elegant whispers, A collection of what-ifs, each a potential key to unlocking the secret of this ancient giant. We will not find a single certain answer in this chapter, but we will explore the wonderful pathways our minds have created to grapple with the impossible. The first and most intuitive of these theories is the idea of hierarchical merging. Imagine the early universe not as a serene, peaceful place, but as a chaotic cosmic dance floor. In those first few billion years, galaxies were closer together, their gravitational pulls more potent. Collisions were not a rare event, but a regular violent occurrence. In this frenetic environment, black holes like tiny pebbles on a fast-moving river would have been constantly colliding and merging. The theory suggests that TON-618 is the ultimate product of this long chaotic process. It's like building a cosmic snowman, rolling one small black hole into another and another and another in a relentless, unforgiving dance of destruction and creation. These galactic mergers would have provided a perfect storm of opportunity for the central black holes to spiral toward each other, radiating powerful gravitational waves as they danced until finally they would collide and fuse into a single, even more massive object. This process, repeated countless times over the eons, could in theory have allowed a black hole to grow to such a staggering size. However, even this theory faces a profound challenge. The sheer number of mergers required to reach 66 billion solar masses in such a short cosmic time frame seems almost impossible. The universe, though chaotic, had its limits. It's a bit like trying to build a skyscraper in a single night. The materials and the time just don't seem to add up. Hierarchical merging might be a part of the story, but it likely isn't the whole story. It leaves us with the feeling that there must have been another factor, another ingredient in the cosmic recipe that allowed for such ferocious growth. This leads us to a second, more exotic and perhaps more elegant idea: direct collapse. Imagine the early universe again, a place full of vast primordial clouds of hydrogen and helium gas. In some regions, due to tiny fluctuations in the cosmic density, these clouds might have grown to an unimaginable size and density. Our usual story of star formation goes like this. These clouds collapse, but not all at once. They fragment, creating smaller, denser pockets that ignite into stars. But what if, in a specific, rare, and extreme circumstance, a cloud was so massive, so uniform in its collapse, that it didn't fragment at all? What if it simply collapsed in on itself all at once, bypassing the stellar phase entirely? This single catastrophic event would not create a star but a superseed, a black hole of immense mass from the very beginning. This direct collapse black hole could have been the ancestor of TON-618. It would have started its life not as a small stellar mass black hole, but as a titan. It would have been born a giant, a king from day one in a universe of infants. This would elegantly solve the paradox of its age and size. It wouldn't have needed billions of years of slow growth because it was simply born big. This is a beautiful and compelling thought, a cosmic shortcut to greatness that our current universe, with its more spread out and sedate conditions, simply no longer allows. It's a tale of a forgotten and perhaps more exciting time in the universe's history. And what of the invisible architects of the cosmos? This brings us to the wonderful and mysterious role of dark matter. We know that dark matter, this elusive, unseen substance, makes up the vast majority of matter in the universe. It acts as the gravitational scaffolding, the invisible framework upon which galaxies and all large-scale structures are built. In the early universe, dark matter would have created deep gravitational wells, invisible whirlpools of gravity that would have drawn in vast amounts of normal matter, the gas and dust that make up stars and planets. This dark matter scaffolding could have acted like a cosmic funnel, channeling a steady, abundant supply of fuel directly into the heart of forming galaxies and right into the hungry mouth of the central black hole. So in this theory, TON-618 wasn't just a hungry giant. It was a hungry giant sitting at a cosmic banquet table that was constantly being replenished by the invisible hands of dark matter. the dark matter halo around its host galaxy would have ensured a constant torrent of gas and dust, allowing the black hole to feed at an unprecedented sustained rate. This could have been the fuel source that allowed it to overcome the slow plodding pace of other black holes, providing a plausible explanation for its mind-boggling size. But let us not forget the mysterious force that is shaping the universe, even now dark energy. This is the force that is causing the universe to expand at an accelerating rate, pulling galaxies further and further apart. In the early universe, dark energy was not as dominant as it is today, but its presence would have still been a factor. How did this cosmic expansion affect the growth of a black hole, like TON-618? It's a complex and beautiful question. The expansion would have, over time, made the universe a less dense place, a less fertile hunting ground for black holes. But in the first billion years, could dark energy's subtle influence have played a role perhaps in shaping the very distribution of matter that fed TON-618? Or is it simply the force that is now and for all time putting an end to the cosmic feasts that once allowed such giants to form? We do not know. And in this not knowing, there is a beautiful, peaceful space for us to simply ponder the complex interplay of these fundamental forces. Ultimately, all of these theories are whispers in the dark. They are our human attempts to make sense of a universe that is far grander and more creative than our imaginations. It is entirely possible that the true answer is a combination of all these ideas, a beautiful tapestry woven from threads of hierarchical, merging direct collapse and the guiding hand of dark matter. Or perhaps the truth is something else entirely, something we have not even begun to conceive of. TON-618 is the magnificent cosmic invitation to dream, to imagine, to build new mental models, and to gently push the boundaries of our knowledge. It is a reminder that the universe is not just a stage for our theories. It is a place where reality itself is a wild and wonderful story, and we are lucky enough to be the listeners, standing in the quiet of the night, pondering the impossible truths it so generously shares. We have contemplated the impossible birth of TON-618, examining the theories that might explain its gargantuan size. Now let us place our cosmic titan within a broader context, comparing it to its kin, the other black holes that populate the universe. In this act of comparison, we begin to appreciate not only the magnificence of TON-618, but also the incredible diversity and scale of these enigmatic cosmic objects. Think of it as a family reunion of cosmic giants, a gathering where we see the quiet ones, the famous ones, and the true awe-inspiring behemoths. First, let's turn our gaze to a cousin we have met before, the black hole at the center of the galaxy Messier 87 or M87. This black hole, a heavyweight in its own right, gained a kind of celebrity status when it was famously photographed by the Event Horizon telescope. The image, a glowing orange ring of light surrounding a dark shadow, was a triumph of human ingenuity, a single snapshot that confirmed the reality of these objects in a way no theory ever could. The M87 black hole, at around 6.5 billion solar masses, is a colossal beast, a gravitational sculptor of a galaxy-spanning jet. It is a powerful example of a highly active supermassive black hole. But TON-618 is in an entirely different league. It is roughly 10 times more massive than its famous cousin in M87. To put this into a more tangible image, if the event horizon of the M87 black hole were the size of our solar system, the event horizon of TON-618 would swallow not just our solar system, but hundreds of them. The M87 black hole is a massive mountain. TON-618 is an entire mountain range. The comparison between the two helps us understand that even within the category of supermassive black holes, there are vast, profound differences in scale. M87 is a magnificent cosmic heavyweight, but TON-618 is a champion that stands alone in a ring of its own making. Now let's look a little closer to home, to a more familiar neighbor. At the very heart of our own Milky Way galaxy lies the supermassive black hole we call Sagittarius A. Keir. It is a quiet, gentle giant, a cosmic anchor around which our entire galaxy gracefully spins. With a mass of about 4 million suns, it is a respectable, but by no means enormous black hole. In the grand cosmic scheme, it is a small pebble compared to the mountain of M87 and an invisible grain of sand compared to the sheer scale of TON-618. The difference here, however, is not just in size, but in personality. Our Sagittarius A is currently in a state of quiet repose. It is a quiescent black hole, gently grazing on the occasional stray gas cloud, but not engaging in the furious, ravenous feast that powers a quasar. It is a sleeping giant, a quiet king on a throne of stars. TON-618, on the other hand, is a roaring furnace, a hyperluminous quasar devouring vast amounts of matter at a furious rate. This comparison teaches us that black holes, like people, have their moods and their phases. Some are quiet and reserved, others are loud and energetic. By studying both, we begin to understand the full spectrum of their behavior, the quiet stillness and the chaotic, brilliant roar. This contrast between the quiet and the loud leads us to a broader category of black holes that challenge our understanding: the ultramassive black holes. TON-618 is not the only one, though it is the most massive we have found so far. The black hole at the heart of the galaxy, Holmberg 15A, is another example. With a mass of around 40 billion suns, it is another magnificent titan that seems to defy the rules of black hole growth. These ultramassive black holes are the true outliers, the cosmic rule breakers that force us to re-examine our theories. They are a kind of different species of black hole, a more ancient, more ferocious lineage that seems to have followed a different evolutionary path. And let us not forget the other anomalies that populate our cosmic neighborhood. There are black holes that are too massive for their host galaxies, a kind of gravitational bully that is far larger than its surroundings would suggest. The black hole at the center of the galaxy, NGC 1277, is one such example where the black hole makes up a staggering percentage of its galaxy's total mass. These objects, much like TON-619, challenge the beautiful, elegant story of co-evolution, suggesting that sometimes the balance between a galaxy and its black hole is not a delicate dance, but a profound, overwhelming dominance. By studying these outliers, we are not just cataloging strange objects, we are building a more robust understanding of the universe, one that can account for the strange, the unusual, and the magnificent. The comparison also highlights the profound importance of age. TON-618 is not just massive, it is a massive black hole from the distant past. This is a crucial distinction. When we look at a modern-day ultramassive black hole, like the one in Holmberg 15A, we are seeing a creature that has had billions of years to grow, to merge with other black holes, and to feed on its galactic surroundings. Its size, while still breathtaking, is more in line with what we would expect from a slow, methodical process over cosmic eons. But TON-618's existence in the young universe is a completely different story. It is a fully formed giant in a cosmic nursery, a paradox that pushes our theories to the breaking point. The comparison between the ancient and the modern giants helps us to understand that the rules of the universe and the speed at which it operates may have been very different in its tumultuous, chaotic youth. By bringing all these objects together, the quiet one, the famous one, the modern giant, and the ancient titan, we are creating a kind of cosmic library. Each black hole is a different book, a different story of creation, evolution, and destruction. TON-618 is not the only story, but it is one of the most important ones. It is a chapter that is still being written, a mystery that is still unfolding, and a magnificent testament to the idea that the universe is far stranger, more wonderful, and more diverse than we could ever have imagined. In the quiet of the night, as we contemplate these magnificent cosmic siblings, we find a certain kind of peaceful humility. We are but observers, standing on a small planet, looking up at the grand silent family of giants, each with its own story to tell. We have journeyed through the mysteries of TON-618's past, contemplating its impossible birth and comparing it to its cosmic kin. Now let us turn our gaze forward and consider the long, slow future of this cosmic titan. What is the impact of a creature of such immense gravity and power? What is the legacy of its existence? And what does its distant light tell us about the ultimate fate of the universe itself? In this chapter, we will not find certain answers, but we will explore the elegant, beautiful, and sometimes melancholic possibilities of its future. The first and most immediate impact of TON-618 is the long shadow of its gravity. This is not a metaphor. Its immense mass creates a gravitational field so potent that it shapes the very fabric of space and time for vast distances around it. It is the gravitational anchor of its host galaxy, a powerful and silent puppet master pulling the strings of stars, gas, and dust. The light we see from the quasar is the result of its ferocious appetite, but the real enduring legacy is the way its gravity dictates the cosmic choreography of its entire local neighborhood. It influences the orbits of countless stars and gas clouds, drawing them into a graceful, millennia-long dance, or perhaps a violent, inescapable plunge. Over the immense scale of cosmic time, this gravitational dominance will have a profound effect on the fate of its host galaxy. The quasar's intense radiation and powerful jets, which we explored in a previous chapter, act like a cosmic pressure washer. They can heat up and expel vast amounts of gas from the galaxy, a process known as quasar feedback. This gas is the very raw material needed for star formation. By blasting it out of the galaxy, TON-618 is in essence putting an end to the birth of new stars. This process, known as galaxy quenching, will slowly transform the galaxy from a vibrant, star-forming spiral into a quiet, more placid elliptical galaxy full of old red stars that are slowly and patiently burning out. The cosmic titan, in its glorious youthful feast, is already writing the story of its host galaxy's long, slow decline. But the story of TON-618 is not just a tale of destruction. Its future is also deeply intertwined with the future of observation itself. The light we see is a message, and as our technology advances, our ability to read that message will become more and more profound. The James Webb Space Telescope, with its ability to see in the infrared, is already beginning this work. It will allow us to peer through the thick veil of the quasar's brilliant light and finally get a glimpse of the host galaxy itself. It will allow us to see the stars and the gas and the dust, to see the intricate, powerful relationship between the black hole and its galactic home. This is the next great chapter in our study of TON-618, a chapter that will move from simply observing the light to understanding the intricate, powerful dance of the host galaxy itself, and what of the universe's ultimate fate. In the far, far distant future, when the universe has expanded into a cold, dark, and empty place, what will be the legacy of TON-618? As the cosmos stretches out, the supply of gas and dust will become more and more scarce. The cosmic feast will eventually come to an end. TON-618 will run out of fuel. Its brilliant, ferocious roar will slowly, gently fade into a whisper. It will cease to be a quasar and instead will become a sleeping giant, a quiet, invisible behemoth sitting in the dark, cold vacuum of a universe that is slowly dying. But even then, its story is not over. The ultimate fate of all black holes, including TON-618, is one of the most beautiful and poetic ideas in all of physics: Hawking radiation. Predicted by the great physicist Stephen Hawking, this theory suggests that black holes are not truly black. They emit a faint, gentle glow of particles, a whisper of energy that slowly, over incomprehensibly vast stretches of time, causes the black hole to lose mass and eventually to evaporate entirely. For a black hole as enormous as TON-618, this process is so slow as to be almost eternal. The time it would take for TON-618 to completely evaporate is a number so large that our minds cannot possibly hold it. It is a time far, far longer than the current age of the universe. So the ultimate fate of TON-618 is not a violent, fiery end, but a long, slow quiet fade into nothingness. It will be a silent behemoth, a ghost of its former self, slowly radiating away its immense mass into the cold darkness of a post-star universe. It will be a final quiet testament to the idea that nothing, not even a black hole of such unimaginable power, is truly eternal. The story of TON-618 in its beginning, middle, and end is a powerful reminder of our place in the cosmos. We are here for a cosmic blink of an eye. The light from this ancient quasar began its journey before we existed, and its story will continue long after we are gone. Its existence, its impact on its host galaxy, and its eventual quiet fade into nothingness are all chapters in a grand cosmic narrative that we are only just beginning to read. In the gentle glow of its ancient light, we find a sense of peace in the vastness of time and space, a humbling reminder of our own smallness, and a beautiful appreciation for the magnificent, unending story of the universe. We have journeyed through the cosmic past, contemplated the impossible present, and peered into the quiet future of TON-618. Now let's leave the world of pure science for a while and step into a different kind of space, the space of human imagination. For an object as grand and mysterious as TON-618, its influence extends far beyond the realm of astrophysics. It is a muse, a symbol, and a canvas upon which we paint our deepest fears and our most magnificent dreams. It is an extraordinary source for non-scientific applications, a silent collaborator in our art, our stories, and our contemplation. First and foremost, TON-618 is the perfect muse for science fiction. For authors and filmmakers, the concept of an ultramassive black hole from the dawn of time is a fertile ground for storytelling. It is a perfect embodiment of cosmic horror, a genre that explores the insignificance of humanity in the face of vast, incomprehensible cosmic forces. In these stories, TON-618 is not just a scientific object. It is an existential threat, a looming presence that challenges our very notion of reality. It could be a gateway to other dimensions, a tear in the fabric of space-time, a place where the laws of physics break down and sanity follows. Its unimaginable scale and its ancient age make it the perfect villain, a silent, powerful abyss that swallows not just matter and light, but entire civilizations and even time itself. But its role in fiction is not always so grim. It can also be a symbol of hope and ingenuity. In other narratives, TON-618 could be a source of unlimited clean energy for an advanced civilization. It could be the engine of a hypothetical Dyson sphere, a megastructure built around the black hole to harness the incredible energy of its accretion disk. For a sufficiently advanced species, the gravitational power of a black hole could be a resource, a tool to be used for interstellar travel time dilation, or even the creation of new matter. These stories, though rooted in fantasy, are a testament to our human desire to not just understand the universe, but to master it, to turn the greatest of its terrors into our greatest of triumphs. This brings us to the profound role of TON-618 in art and music. Black holes are by their very nature invisible. They are defined by what they are not, a void in the fabric of space. This absence of light forces artists and musicians to imagine, to create, to interpret the unseen. Artists have created breathtaking visual representations of TON-618, often portraying it as a monstrous swirling vortex, a maelstrom of light and color that is both terrifying and beautiful. These images, often a blend of scientific data and artistic imagination, help us to grasp the ungraspable. They give us a face for the faceless, a form for the formless. They force us to confront the immense scale of the universe in a way that numbers alone cannot. Similarly, musicians and composers have been inspired by the immense power and quiet mystery of black holes. Some have created ambient soundscapes using deep resonating bass tones to evoke the feeling of immense gravity and vast empty space. Others have used mathematical models of black hole physics, translating the equations of general relativity into complex ethereal sound patterns. a kind of cosmic music born from the very laws of the universe. TON-618, in its quiet ancient roar, is a kind of universal melody, a grand symphony that has been playing for billions of years. And artists are our humble interpreters, translating its song into a form our human senses can begin to understand. But perhaps the most important and beautiful, non-scientific application of TON-618 is its role in educational outreach and public fascination. For educators, this cosmic titan is a powerful, almost magical tool. It is an object so extreme, so magnificent, that it instantly captures the imagination. When we talk about TON-618, we are not just talking about a scientific object. We are telling a story. We use simple, tangible analogies to help people grasp its incomprehensible scale. We compare its mass to an Everest-sized grain of sand, its event horizon, to our entire solar system. These analogies are like little ropes we throw out to a drowning mind, giving it something to hold on to in the vast, overwhelming ocean of cosmic numbers. TON-618 allows us to teach complex concepts like quasars, accretion disks, and cosmic redshift in a way that is engaging, exciting, and deeply memorable. It is a portal to the world of astrophysics for millions of people who might otherwise never have been interested in the subject. It is a reminder that science is not just a collection of dry facts, but a magnificent story full of wonder, mystery, and awe. Finally, TON-618 can serve as a profound point of contemplation for our search for extraterrestrial intelligence, or SETI. For a civilization that is millions or even billions of years more advanced than our own, a black hole like TON-618 could be more than just a scientific curiosity. It could be a kind of cosmic lighthouse, a universally recognizable reference point in the vast empty darkness. A signal could be sent from a distant galaxy, a beacon of light or radio waves that is aimed at TON-618. Or perhaps the immense energy of its accretion disk could be harnessed to power the transmissions of an entire galactic civilization. By looking for signs of artificial energy manipulation around TON-618 or other ultramassive black holes, we might be looking for the technological fingerprints of a species so far advanced that they have learned to use the very fabric of the cosmos as their canvas. So let's rest our minds on these ideas for a moment. TON-618 is not just a scientific puzzle. It is a kind of cosmic mirror reflecting our own fears, our own ambitions, and our own profound sense of wonder. It is a symbol of the great wide universe and all its mysteries. And in its brilliant ancient light, we find a reflection of our own creative spirit, our own insatiable curiosity, and our own beautiful, enduring desire to tell stories about the things we do not yet understand. And so we arrive at the final chapter of our quiet journey. We have taken a cosmic stroll, hand in hand with metaphor, through the grand and mysterious story of TON-618. We began with its impossible light, a whisper from the distant past, and we have traveled to its colossal heart, a black hole of unimaginable scale. We have marveled at the long, slow unfolding of its discovery, witnessed the violent beauty of its cosmic environment, and pondered the scientific riddles it has so generously offered us. We have compared it to its kin, the other black holes in the universe, and we have imagined its long, slow future, a gentle fade into the cosmic darkness. Finally, we have stepped back from the science to see its reflection in the mirror of human imagination, a muse for our stories, our art, and our dreams. Now let us bring all of these threads together, not to form a neat conclusion, but to weave a final peaceful tapestry for our thoughts as we drift toward sleep. The story of TON-618 is not just a story about a black hole. It is a story about the universe itself. It is a testament to the idea that the cosmos is a place of beautiful extremes where the gentle whispers of starlight can originate from the heart of a violent, chaotic maelstrom. It is a reminder that what we see as solid, unchanging truths are often just the first tentative steps on a much longer journey of discovery. The first great lesson of TON-618 is the humility of scale. We are creatures of the Earth, a small vibrant planet orbiting a single, ordinary star. Our minds are built to comprehend the small and the tangible. But when we are faced with a number like 66 billion suns, a distance of 10 billion light years, or a brightness of 140 trillion suns, our mental models break down. This is not a failure. It is a gift. It is the universe gently reminding us that it is so much more magnificent and so much more vast than we could ever have conceived. In the face of this scale, our worries and our daily dramas become as small and fleeting as dust motes dancing in a sunbeam. There is a profound peace in this, a kind of cosmic perspective that places our own lives within the context of a story that is far, far older and grander than our own. The second lesson is the beauty of the unknown. TON-618, with its impossible size and its improbable age, is a magnificent testament to the fact that our scientific story is far from over. It is a puzzle with missing pieces, a book with chapters yet to be written. The existence of this cosmic leviathan, a creature that defies our best-laid theories of black hole growth and galactic evolution, is not a problem to be solved with urgency, but a beautiful mystery to be cherished. It reminds us that our quest for knowledge is not a race to a finish line, but an endless, joyful journey of discovery. In the quiet of the night, we can find a certain comfort in the knowledge that there are still so many beautiful, elegant truths about the universe that we have yet to uncover. The third lesson is the interconnectedness of all things. The light from TON-618, which began its journey when the universe was in its infancy, has traveled for billions of years to reach our telescopes. This single photon of light is a profound link between our present moment and the universe's ancient past. It tells us that the universe is not just a vast empty space, but a living, breathing, interconnected tapestry of time, space, and energy. The gravitational field of TON-618 and its powerful jets of radiation have shaped the destiny of its host galaxy for eons, and its light has traveled for billions of years to shape our understanding of the cosmos today. We are all a part of this story. We are all connected in some way to that distant, beautiful, and impossible light. As we bring our journey to a gentle close, let's return to the image that started us all, the brilliant, distant beacon of TON-618. For now, we do not need to understand every detail of its formation or every equation that governs its immense power. For tonight, it is enough to simply listen. It is enough to feel the gentle rhythmic hum of the universe, a song that has been playing for 13.8 billion years, a lullaby from the edge of time. TON-618 is a single powerful and magnificent note in that song. Its existence is a testament to the wonder of the cosmos, to the beautiful mysteries that lie hidden in the quiet darkness, waiting to be discovered. So let us find a kind of peace in the vastness. Let's find a certain kind of calm in the knowledge that we are small, but we are also a part of something unimaginably grand. And as you drift towards sleep, let the image of that ancient beautiful light fill your mind, a light that has journeyed across 10 billion years, a message from a cosmic giant, a gentle and peaceful reminder of the immense and wonderful story of the universe. Good night, sleepy thinkers. May your dreams be as vast and beautiful as the cosmos itself.